Welcome to the next coding video of RetroRemakes. In this video we will take a closer look at the central script for that project. It's on the rolling ball and it's the player controller script. Let's open it up. And you can see here that it's a very long script that does many things. And there's plenty of room to optimize that, to split the script up into smaller scripts, and we will certainly do that in one of the later videos. I have left it that long for several reasons right now, because first, it is easier to explain when everything is in one place and we don't have to jump from class to class. And the second reason is that you should not be afraid to write long classes. You may have read about clean code and clean architecture and so on, and how you structure your code. But when you're starting out or when you're making a new game, you shouldn't limit yourself in your head by thinking, oh, that's not good, and I have to structure that differently, and I don't know how, maybe I shouldn't write code at all. So the first thing when writing code is to make it work, and then you can restructure it later on. So right now it is all in this big class, and we can explain how everything works together. And in a later video we will try to clean that a bit up and also give explanation why that is a good idea. So let's start from the beginning of the class. You can see here I have defined an enum called extra type, and this lists all possible extras the player can use. And because I will be mentioning the extras a few times in this video, let's take a look what they are. In the game you have this green window here, and if you press the right mouse button you can cycle through the available extras and activate them by pressing the left mouse button. You have to buy them first or collect them in the map, and then you might be able to use them. For example, if you have that hammer, you can close holes in the ground. Or if you're having that spiked ball, you will be able to navigate over ice tiles on the floor more easily. And you might notice that these are grayed out, so this enum is not used anymore. It's a leftover from the old version. And in the next video, when we will take a closer look at the extra system and how I redesigned it from the first version, I will give you an explanation how it was before and how it became the version that it is now, and also the reasons for that. So this is no longer used here, but I will explain why I had this here in the first place in the next video. Then in the player controller class we have a lot of variables declared here, and again that is not the best sign and is probably a good indication that we can split up that class into several smaller classes. But for now let's go through them real quick. First we have defined a few constants we will use in the class. Then we have an event that is an action, and that is not a Unity event, but it works in a similar way. That is the action that the system package of C# brings with it. And it works in a similar way to the Unity events, where you can take methods and subscribe to that action, and when the action gets triggered, all the methods that are subscribed will get called. We will take a closer look at that in a minute. Here we have variables for the selected extra or the activated extra, and we will take a closer look at that in the next video. And here we have a few variables for the state of the ball, if it is disabled or the player is dead, the timer is paused, the max speed, and so on. We will also keep track of the spawn position, the velocity, the applied force to the ball, and so on. And we will cache a few components on the start, so for performance reasons we don't have to look them up in the code every time we want to use them. Then we have a few fields here that are serialized in the inspector, so you can enter values there during the gameplay or in the editor. Let's take a look. These are the fields here. And some of them are filled during design time. So for example, all the tile maps that are used by the player controller are set up here, and also the textures that we use for the ball. And some are just exposing the inventory of items you have. For example, red keys are 0, and during the game you can enter a value here, and then you will automatically have red keys to open, for example, that lock, and you don't have to pick up the red key before that. Then we have a list of properties. Properties are similar to variables, but with the added functionality that you can define what happens when you get the value from that variable and when you set the value to the variable. So let's take a look at the score property, for example. When we have that property with a capital S for the score in the code, then when the value is needed from that property, then the get method is used and just the private variable level score is returned. But when we set the score with a capital S, then also the level score variable is set to the new value. But we also do other things. For example, we increase the total player score in the game manager. So the game manager is alive during all of the scenes, and when a scene ends, then the level score will be lost. So we need to store the total score of all levels in the game manager. And that is done here. Whenever we increase the level score, when we're picking up a diamond, for example, then the total player score is increased as well. And here we find the action I mentioned earlier, and we use it here to tell anyone who's interested in a change of player data that player data indeed has changed. For example, when the score gets increased, we use that action and invoke it, and then everyone who's subscribed to that action is informed by that. I can give you an example. The UI manager has a field here for the score, and whenever we are picking up a diamond, that green one for example, then the score in the UI needs to get increased. So in the first version I had here, I just had UI manager instance update score text, and then I can enter the level score here, and the UI will be updated. And that is perfectly fine to do so, but the action gives us the possibility to separate the player controller and the UI a bit better. So right now the player controller does not need that the UI manager even exists or that the UI exists. It's the task of the UI manager. In the start function, it will get the player controller and the action on player data change and subscribes with the update player info method. That means whenever player data changes and this action is invoked, then also update player info is called here and the UI is updated with the new values. That way the player controller doesn't need to know about any classes that may be interested in the data. It just tells anyone, here my player data has changed, do whatever you want with that information. And this is useful, for example, if you want to have a logging functionality that keeps track of all changes of the player data. When you want, for example, track when the player collects a diamond or picks up a key and so on, then you would write another script called logger. And then you don't need to go in here in every property and say data logger instance log item or similar to that. The player controller doesn't need to change at all. All the data logger has to do is to subscribe to that event, and then it will get informed as well. And you have that on all the properties here. For example, when the money rises, the action gets triggered when we pick up a key, and so on. When we change our selected extra, when the energy is changed, when the lives are decreased, and so on. Then we have a few properties here that are just for shortening the name. I don't know if it's a good idea or if it's a popular idea. I haven't found much about it, but I thought it was quite useful for me. So let me quickly explain what that does. In the code, we're making a few comparisons to tiles. For example, we need to check if we are still on a floor tile or if we are hovering over the void and need to fall down. And for all those comparisons, we would need to write _tileCollection.floor. And that's a bit long and makes the code a bit more unreadable. So I decided to shorten it to just the property floor or correct wall 01 and so on. So you can see the difference here. Instead of writing this, we can just write if title equals floor. And I also made a property for sound manager in that way that we don't have to write soundmanager.instance.play, but just can use sound manager without the instance. Let's continue with the start method. Here you can see a few components that are looked up in the player object and are cached in these private variables. And we're also setting up a few variables we use often in the code. And we set up our contact filter that is used for the collision. We will get to that later in the script. And below that, we have the maps, the tile maps that we use in the script. And these are assigned here directly. So usually you would drag and drop the tile map from here into that slot here. But in case you have forgotten to do that, these 3 lines will try to find the game object with the tile map on it and assign it here. This is done by using find game object with tag. And let's select the floor layer with the tile map for the floor. And you see it has a tag floor map assigned. And finding objects with tag is not the best idea because you might change the tag name or you might even misspell it. So if you write something like that, and you might wonder why doesn't that work, and it might take some time to find that error. And if you are using this string, the floor map string, at many positions in your code and you change the name of that tag, then you need it to change everywhere in your code, and that's quite a hassle. So what I did was making a class, that's a static class with a few constants where I store my tags in the game. For example, the player, special tile object, floor map, and so on. And that is the advantage when I want to change the name of one tag. I can do it here at one position, and everywhere else in the code I will use tags floor map, for example. And that is also the advantage when I start typing tags dot that I have this list here to choose from and I can't type anything wrong. The next interesting part is how we find the spawn position for the player. After every respawn, we want to set the player to that position. And we have a function for that, find spawn position. And all that does is to cycle through the whole floor map in X and Y direction and looks for a special tile. And that is the floor spawn upper right tile. We will take a look at that in a minute. And then it returns that position in world space. Let's take a look at that special tile. Here you can see the starting position where the player starts from. And it's that one here in the tile palette, and in every level you can just put it anywhere you like. And the tile we are looking for is that here. That's the spawn position upper right, and on the map it is this tile here. And the world space coordinates of each tile is measured in the lower left corner here, so we get exactly the middle of that starting pod. But we have to do one extra step to get the world position, because the tiles are stored in integer coordinates, and this means they are independent of the world space and have their own coordinate system. And you can, for example, take a tile map, the floor map in that example, and use the getTile function, where you use vector3int as a parameter and insert the coordinates of the tile map, and then you get the tile at that position. And if you want to know the world space coordinates of that tile, you have this helper function cell to world, which converts the tile position, for example, for the tile x equals 10 and y equals 5 to 200.5 and 100.5 in the world space. And you need the world space coordinates to position your rolling ball. So this position here is world space, and the tiles have their own coordinate system that is not equal to this world space position of the ball or other game objects. Let's go back up. And we set the player transform position to the newly found spawn position at the start, of course. We set the lives to 3. And you can see here we're using the property of the lives and not the private variable. Let's jump there. That's the property. And by setting the lives to 3, the private variable lives get set to 3. And also that action gets triggered, so the UI will get informed and update the fields in the UI accordingly. Then the player also subscribes to an event in the UI manager on hide map that is used when the minimap is shown, because then the player is disabled, so they can't accidentally fall into the void while the map is shown. And when the map is hidden again, then the player is enabled again. We will take a closer look at that when we're looking at the UI manager and the minimap. Lastly, we have a small workaround here. In the item map, we get the tilemap collider component and set the useByComposite flag to false and immediately again to true. You might remember from the introduction that the item map and all its items have their colliders, and we have a composite collider that combines all the colliders to one big collider. And the tilemap 2D component has this checkbox here, useByComposite, and that is unchecked and checked again at the start of the game. And the reason for that is that we have some tiles that are rotated here. For example, this tube, we have it in the tile palette in that way, and if we keep it that way, we can only have tubes in that direction, but of course we want to have those tubes as well, and for that we need to rotate them and place them here. Let me change that to the item layer. But the bug that I mentioned, and for that we have the workaround, is you can see the colliders for that tile. It's the small triangle. And when we don't use the workaround, what happens when we start the game? This collider will be set to this region here, because that is how the original tile looks. Let me place it here. You can see this is the original rotation and the collider. And we don't want the collider here. We want to rotate it also. And that works in the editor, but when we start the game, it will be copied here in that corner. And we need to change that, and that is done by the workaround. We need to deactivate the composite collider once and then activate it again. Next method we have is onPlayerDataChanged. That just invokes the onPlayerDataChanged action, and we have it here so we can use it from other scripts, and that is used from the extras we will get to in the next video. Then we have the find spawn position we explained right now, and then we have the update method, and that is called every frame, and all these functions here are executed one after each other. The first is calculate timers. You can find it right below here. And right now we have two different timers here. For example, the level time that gets increased with every frame. So we keep track how long the player has state in that level. And again, we use the property for that. Let's jump there. And that also invokes the onPlayerDataChanged action, so the UI gets updated automatically. The other timer we have is the seconds on current tile. That keeps track how long the player is staying on one tile. And a use case for that is these cracked tiles. Let's grab our ball. When a player enters the tile, it will change to a whole tile. Like you can see here, that is the progression of those cracked tiles. It first changes to a small hole, then to a big hole, and then the tile vanishes completely and the player will fall into the void. But the small hole should not appear immediately when we enter the tile, but instead we need to stay a bit longer on the tile and it will change to that hole after a short while. And you can see when we change the tile position we are on, the current tile position we are on is not the same like the last tile position in the last frame, then this timer will be reset to 0. And we also need to reset the timer when the floor tile changes, for example. So when the ball is staying on that cracked tile, for example, and after 0.5 seconds, this whole tile appears. And the rule is after every 0.5 seconds, the tile gets a bit worse and the hole widens. Then if we don't reset the timer, then it will also be above 0.5 seconds and automatically, immediately, the next tile change will be triggered. So we need to reset that after that small hole appears to 0 seconds and wait another 0.5 seconds, and then the big hole can appear. So that is the reason why we need this check here. The next method we call here in the update loop is check mouse buttons, and that is directly below here. And we differentiate if the player is dead or not. If they are dead, a message is shown telling the player, hey, do you want to restart the whole level or do you want to respawn from the last safe position? And when the player presses the right mouse button, here indicated by the 1, then the level gets restarted, and pressing the left mouse button, the player is respawned. And when the player is playing the game and is not dead, then a right mouse button will cycle through the extras and a left mouse button click will activate the currently selected extra. The next thing in the update loop is we check if the player is disabled, for example, when they are watching the level map, or when the player is dead, then we don't want to continue here in the update loop and move the ball and check for collisions and so on, but instead return until the next frame. But if we are still in the game, then the next method that gets called is move ball. That's below here. And what that basically does is get the input from the mouse in X and Y coordinates and also from the keyboard, so you can control the ball with your mouse or with the keyboard and adjusts the values a bit, and then applies them to the rigid body and changes the position of the ball accordingly. And all the other stuff that is happening in here is used to influence the kind of movement the ball is taking in reaction to the player input. So to make the movement a bit more physics-like and to give it a bit of inertia and gravity, we don't apply the movement of the mouse directly to the position, but we are increasing the force the player influences on the ball. And then the force is added to the velocity of the ball. The velocity is also divided each frame by a dampening factor, so when no force is applied, then the ball will slowly roll out until it comes to a stand. Then the velocity is capped, so we can't increase the velocity endlessly. And then, like I said before, the position of the ball is calculated by adding the velocity that can be positive or negative. Finally, we also use that velocity to offset the texture of the ball, and we will take a look at that in a minute. I want to mention this for scale here before that. That is a factor that can influence the force. Let's control click on it to go to the definition, and then control click to see where it is used. You can see here directly it is initialized to the scale of 1, so nothing is changed from our input to the force. And here you can see where the force scale is actually changed. We can click on that, and it's when we are checking the floor material we are on, and when we are on an ice tile, then the force scale is set to 0.5. So whenever we are applying force when we're on an ice tile, it's not that impactful as it would be on a normal floor tile. So when we're back on a normal floor tile, be it floor or a crack tile, or crack tile 2, crack tile 3, then the force scale is set to 1 again. And also on the ice tiles, the velocity dampening is 1, and on normal floor tiles it is 1.005. That means on ice tiles the velocity will never get decreased and the ball will slide endlessly. Let's jump back to our method move ball. Here you can see we divide by the velocity dampening, and on ice we divide by 1, which will have no effect on the velocity, and dividing by 1.005 over time velocity will decrease. The second thing I want to mention is that we don't set the position of the game object directly by using transform.position, but instead we're using the rigid body. And the reason for that is, let's close the tile palette. You can see the ball has a circle collider attached, the green outline here, and that is tied into the physics system. And when we're trying to move the ball in the game, then the circle collider does not necessarily change its position on the same frame as the ball changes its position, because the physics calculations are running on a different frame rate, and that might lead to the effect that the ball moves, but the collider has not yet moved. So basically you would end up in that scenario. And that is something we don't want, because when the ball moves here into that obstacle and the collider is still here, then the collision with the obstacle is not detected, and that leads to very weird behavior. So whenever you're moving objects with colliders and that have something to deal with physics and collisions, then always use the rigid body 2D or rigid body in the 3D space. And for the texture offset, let's take a look at that. Like I said in the introduction, we have a special shader here that spherifies the texture of the ball. You can see here it's a very flat texture, and the shader bends that texture so that it looks like a sphere. But with the illusion of the ball moving, we can't just move it here. We have to also animate the texture, and that is done by setting this offset here. Yeah, you can see how the ball seems to rotate. We have a texture offset here where the velocity gets subtracted from, because when you're moving up, let's look at the coordinates, the position. We're moving up, then the y position is increased. It's from -14 to -12. We're moving up. So we're adding to that position. But we're subtracting from the y position of the texture so that the ball appears to roll upwards. And that is of course just a variable in here. We need to tell the shader or the material about that. And we have a reference to the material here, and we use setVector and the name of the variable in that shader, and set the tiling and the texture offset here with a new vector 4. These are these 4 values: tiling x and y and offset x and y. One more thing, in case you're wondering, how should I come up with that solution? How should I know about those velocities and forces and dampening? Let me tell you, that is something that needs to evolve over time. I didn't write that code from top to bottom and it was correct. I started with just applying the pure mouse input to the position and it looked a bit dull, and I thought, okay, how can I improve it? Let's maybe take a force, and then I played around with that. I played around with values, with maximum force and the dampening, and it took quite a while until it felt right. So I invite you to experiment in these situations. You don't have to get it right in the first try. It was very fun to tweak it until it felt right. Next we have the refresh tile variables, and instead of scrolling, let's just use Control and click on that method. It's directly below the move ball method. And what that does is setting the tile variables for the positions and the tiles in each frame. So we have the last tile position and the current tile position. And in each frame, we're setting the last tile position to the current tile position. And then we're recalculating the current tile position according to the position of our ball. And that tile position is not the world space position, but the vector 3 int. That means it's the position inside the tile map. Like I mentioned, the tile map has its own coordinate system. And to get the position of the tile in the internal coordinate system in the tile map from the position in world space, we have this function world to cell. If you remember, we had the cell to world method a bit earlier to calculate the world space position of the starting tile, where the ball has to start. And here we do the opposite. We use world to cell to calculate this transform position of the ball and see what tile position in the tile map that is. And we do the same for the tile variables. We remember the tile we were last on, and then we're calculating what type of tile, that is here a tile base variable that stores, for example, we were on a floor tile or a cracked floor tile or an ice floor tile and so on. And that is calculated by asking the floor map get tile on the current tile position. And these variables, we had a look here in the calculate timers. If current tile position is not equal to the last tile position, then the timer is reset and so on. And these variables are calculated here in the refresh tile variables. And here in the last part, we keep track of the last save tile the player has been on, and that is if it was a floor tile and there was no obstacle at that position, and in the item map there was also no tile present, then the last save tile position is considered the current tile position. Let's take a look at the map. Let's say the player is rolling around here and rolling a bit too far and falling here into the void. Then the player has the option to respawn, and the respawn point is the last save tile position, and that is here. And if we're coming from the other direction from here and fall into the void, then the last save tile, that was a floor tile and had no obstacles, is here, and the respawn is at that position. That is a very easy system, but it has its limitations you should be aware of. For example, we have here the cracked floor tiles, and when we roll over them a few times, then we have holes in here. And when these 4 tiles are holes and we're rolling into them, then we fall into the void, and the last save position is considered here, and we will never be able to return over that bridge. So it's good to think about that when you're designing a new level, that the player can't get trapped easily. So let's go back to our update loop, and after moving the ball and refreshing the tile variables, we need to check for collisions, of course. Control, click, we jump to that, and that's directly under refresh tile variables. By the way, the order of the methods is not important. You can change the order around, in case you're wondering. That has no influence of the execution, but it is good practice that they are ordered in that way. So, for example, when you're here in the update method and the first method calculate timers, you won't have that very close, so it's directly under here. And the click mouse buttons is directly under there. So you don't have to scroll wildly through the class. Of course, you can always use Control click and jump to that method, but it's good practice anyway. So the collision in that game is a tiny bit special. Usually you would have the onCollision enter 2D methods Unity brings with it. So when two objects collide and you have an onCollision 2D enter method on the objects, then that method will get called and you can do stuff. But then you have to rely on the physics system. And there were some occasions that I found where the physics systems made my life harder than easier. For example, when the ball was glitching or accelerating at absurd speeds and jumping out of the level. So in this project, I wanted to try a different approach, a very basic approach, also to keep it in the retro spirit, because the coders in the early days of the Amiga games had no onCollision enter 2D functions or had no physics systems. So I had to look what else Unity has to offer. And if you have inspected the scenes a bit, here the rolling ball, and you take a look at the collider, you might notice, that's a trigger. And the obstacles layer, that's not a trigger, but usually if you have the onCollision enter 2D, a trigger won't collide with the collider. It will just get through. And I made it a trigger so that I don't have these weird effects the physics system sometimes produces. So let's take a look how the collision system works in that game. If you want to be really, really retro, you can make your own data structures for the colliders and then check for overlaps. You can check if a circle overlaps a rectangle and so on, but that was a bit too complicated to implement here. So in the end, I relied on the physics system, but not the onCollision enter 2D methods you usually use. And they are perfectly fine. There's nothing wrong with that. But I think it doesn't hurt to have other tools in your tool belt as well. So for this game, we're using the physics 2D package, yeah, but we're using the overlap collider method. And what you can do with that is you check if one collider hits any other collider. And you do that by giving a few parameters here for that method. The first is the collider you want to check. And in our case, it's the circle collider of our ball. The second and third parameters are the contact filter 2D and collider results. And let's jump to the definition by holding Control and clicking on that. It is here. And then again, Control click, we can see where it's set up here in the start method. And what a contact filter 2D is, basically, it's just a filter for contacts the overlap collider method might detect. So the method will look at the circle collider and see if there are any contact points with other colliders. And then it will only keep those results that you specify here in the contact filter 2D. For a normal collision, we want to look at every physics layer except the data layer. And that is that expression here, layerMask.getMaskData. That gets us the physics layer of data. And then we use this operator here that inverts the mask totally. So every layer is activated except the data layer. And the inverse is true here for the data contact filter 2D. Here we are only interested in the data layer. And if you remember the teleporters from the introduction, let's take a look in the scene to clarify that. Let's find a teleporter, for example, here. That teleporter is on the items layer. And the items layer, or the item Tilemaps, I have to say, is on the default layer. So our contact filter would not filter out a collision with the default layer when we are colliding with that object here, because it is not on the data layer. And the data layer, if you remember, is under the items You can see it's on the data layer, and here we have the teleporter data stored. So back to the code. For normal collisions, we are interested in everything except the data layer, and then for asking what data is relevant for the tile, we are interested in collisions with the data layer. We will take a look at that in a minute. And the contact filter also allows you to specify if you want to detect collisions where are triggers involved as well. So let's jump back to the check for collisions method. So you give this contact filter for normal collisions with normal objects in here as a second parameter, and then you have the collider results that will store all the results the overlap collider will find. And since the overlap collider method may find many results, this is an array, and then we can access all the results by accessing the array. And the result of that overlap collider method is a number, and that will tell you how many results were found. So basically it's how many results were written into that array. And if the number is greater than 0, then a collision has occurred. And in that case, we need to do something. Otherwise, there's nothing to do for us here. So when a collision occurs, we will assume that we cannot pass the object we have collided with. And that is indicated by that bool variable can pass is set to false. But then, of course, we have to check what collision it was that has occurred. And we're checking that by looking at the collider results that were populated here. And that is the first result that was placed into that array. And we can be sure that there is at least one result because we have checked here how many results there were. So we get the first result with the 0 index, and then you can see what the collider result has in store for us. And you should check the online documentation for Unity for that if you're interested in learning more about that collider result object. But one thing it provides is the game object where the collision has occurred on. And here we are comparing if it was the item map game object. That means if our ball has, for example, collided with a key that is on the item layer, and that has the collider, and when our ball enters the other collider, then we have a collision result, and the game object of that collision result will be the item game object. And in that case, we know we have collided with an item, and we check that item at the position of the collider result. And the collider result also provides a method closest point, and with that you can check the closest point between the position of the ball and the collider result. And let's take a look at the map. When we're selecting those two, we can see both colliders, and this is the position of our ball, and then we just calculate the closest point between our ball and the collision that has occurred. And then we will find a point here that is intersecting with the key, and that gives us the possibility to check what item is at that position, because that is a tile. Let's go back to the tile palette to see that a bit better. You can see here it's the whole white square where the key is in. So by getting this position, the closest point, we will also be able to detect what tile that is, and then we can ask the item tile map, hey, what tile is there? In this case, it's the yellow key tile. And the check item position then returns if we can pass an item or not. Usually you can just pick up the key or pick up a diamond, and can pass will be true. So when we enter here and can pass gets set to true, then we don't need to stop the ball, we can just roll on. And similarly, we check in the next step when we have not collided with the item map game object, if we maybe have collided with a special tile object. And these are, for example, these tiles that get replaced with game objects on the game start. So we need to start first to see one of them. Let's pause. And you can see here the sliding door is the replacement for the tile of the sliding door. You can take a look in the introductory video why that is necessary. And these objects are marked with the special tile object tag. So in this case, we check a special tile object, also return if we can pass or not. And finally, if it was not an item or a special tile object we have collided with, we check the obstacle map. And usually you can't pass anything on the obstacle map except you're breaking a wall, for example. And the check obstacle at position does the same like the check item at position or check special tile object, and returns if we can pass or not. And then when we have run through all these possibilities, in the end we check, can we pass or can we not? And if we can't pass, then we need to bounce off the obstacle. And you can find that method right below. And here we're using Physics 2D again to calculate the distance between our circle collider and the collider result we have collided with. In that collider distance, we have the normal vector in what direction we have collided with the object, and we have a distance, how far away that object is. And with that, we can create a movement vector that has the direction of the normal and the distance to the object we have collided with. And then we take the rigid body and reposition it so that it is moved by that move amount. And that means, for example, if we collide with that wall and we are in that wall already, the physics system doesn't save us here because that is a trigger and we don't want to use the automatic calculation of the physics system. We want to do it by ourselves. So what we need to do here is bounce back that we are here and don't intersect the wall. And what that distance calculation does is detecting, okay, we have the vector of the collision is that direction, and the distance that is calculated is that distance here. So when moving our ball by that distance in that direction, we end up here again. So we don't intersect the other collider anymore. Then we also cap our velocity a bit. We set it to 35% of the original velocity, so we don't bounce back with the same speed we came in, but a bit slower. And then also we have some calculation in which direction we want to bounce away, because when we're bouncing directly on the wall, it's best to bounce back in that direction. But if we're bouncing from here in a straight angle, we want to bounce here away, and the opposite is true. So that is what these two lines do. They change the velocity we are bumping away with, and then our velocity is set to this bumped velocity, and our force we have applied last with the mouse input is set to 0. So let's take a look in the game how that looks. You can see here what the effect is. And again, that is something I had to figure out over a few days even, so don't be worried if you don't get it right the first time. It may take a while to get the desired result you want from the ball behavior. Now let's take a look at the check methods here, the check item position, for example. What we give in here is the position of the collision between the ball and the item we have collided with. And we know it's an item, so we first calculate the item position by asking the tilemap, please convert the world space coordinates to cell coordinates, and then we get the item at that coordinate. So in our example, we would have the yellow key here as an item. And here you can see all the results for the can_pass variable. If we pick up a diamond or key, or if we unlock a door or use a teleporter, we will always be able to pass and not bounce off that obstacle. An exception is here when nothing of these checks hold true, then we will bounce back. That is, for example, when we collide with a door and we don't have the right key to open the door. Let's take a look here at the pickup key item to stay at our example with the yellow key. Here it is checked if the item we have collided with is the key yellow or key red or key green and so on item. And if it was the key yellow item, then the key's yellow is increased. And you can see by the capital K, that is the property that also updates the UI. For every key we collect, we increase the score. And then, of course, we have to remove the key from the map. And that is done by going to the item map and set the tile at the position of the item to null. So instead of having the key yellow tile at that position, we don't have any tile and the key will no longer be seen. And you can see here it's similar to the other pickup methods. When we're picking up a diamond and it's the yellow diamond, then we have a score of 100. The red diamond gives a score of 300 and so on. We have a few specials here, of course, not just picking up items, but also unlocking the doors, for example. So when we are encountering a lock yellow, that is the item we have collided with, and we have more than 0 keys yellow, means we have already collected a yellow key or we have set one in the inspector, then we will decrease our yellow keys. We have used 1 key for that door, and that door is opened by setting the tile at that position to null again, increasing our score, and returning true because we have opened the door and we don't need to be stopped. And when we don't have a key for that door, then we can't open it and we return false. And you can see here, if unlock item was true, we return true. And if it was not true because we couldn't open the lock, then we return false. And that will then be the returning value for that check item at position, and that will be false, which will cause the player to bounce back off the obstacle. The other special thing is to use the teleporter when we're colliding with the teleporter item. Here we check if the item is the teleporter tile, and if it's not, then we return false and go on with the other checks. But if the item was the teleporter indeed, then we need to check for the data layer to get the destination where we want to go to with that teleporter. And here we use the same method, overlap collider, again with our ball, and we're collecting the results of the collision. But in this case, we're using the data contact filter that only contains objects in the data layer. Let's take a look in the scene again. That's this data layer here. And when we position our ball here to the teleporter, then you can see this teleporter data object. It's that one here. And when we're making the overlap check, then the result will be not that we're colliding with the teleporter, because that is not on the data layer, but we're colliding with the teleporter data object. And that gives us the possibility to query what the destination of our teleporter will be. And that you can see here, we are checking for results, data collider results, the first element, check the game object, and that is the data object for the teleporter. We get the component teleporter data and the property destination. And we use that world space destination to feed into our teleport to method. Let's jump into that. Upon teleportation, the player is disabled, so they can't move anymore. And we start a coroutine to animate the effect of the teleportation. and the coroutine is called teleport sequence. We also give it the destination. And here we start a coroutine on the UI manager to fade in the white teleport layer so that the screen is fading to white completely. And then we set the player to the desired destination, and then the white panel will start to fade out until the level is seen again. After teleporting, for safety reasons, we set the velocity to 0 because we can teleport near to the void, and when we're having full speed running into the teleporter, we might just roll in the void. And so we set it to 0 and we enable the player again so they can move again. Let's jump back. And this happens in parallel. The player can't move, but the teleportation is going on. And here we return true, and the collision does not have to bounce the player back. Pick up coins is the same as picking up keys or diamonds. And catch explosion damage is when we're running in the explosion we can trigger when we put a bomb on the floor. And when we're colliding with such an explosion, then our energy will be decreased in every frame that we are colliding with that bomb. And then we have, of course, our nice tubes we can ride. And here we check if the item we have collided with is the tube entry tile. That is that middle part here. When the ball collides with that tile, then the right tube sequence gets triggered. And here we have also a small safety check that we can't accidentally enter the tube from the side. For example, when we're rolling from that direction in here, that should not work, of course. We should only enter from here. And that is ensured by checking for the tiles to be on the right positions along the entry tile. And here you can see an old implementation and the new implementation of riding the tube. And the old one was based on data, like with the teleporter. Here we have checked if we can find a tube data similar to the teleporter data, and in the tube data was configured how the path of the tube was, and then we have traveled from one tile to the next by looking into the tube data, and you can check it out down below if you're interested. But then I decided it's not necessary to store that data, and it was also a lot of work. If you have a long tube, that is maybe not the longest tube, but if you have a very long tube, you have to enter, okay, we have to go left, left, down, 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 right, and so on. And that's really not needed because you can see the tube here and the data is in the tile map, and we can just pass the tile map to see where the next tile is we have to go to. And that is what is done here with the right tube without path. And I left that in here for you to study if you're interested. Usually you would remove old solutions that you don't use anymore. And again, like the teleporter, we are disabling the player so they can't move in the tube. They are transported automatically in the tube, and then we start the right tube sequence, which is a coroutine. So when we're colliding with the entrance of a tube, then we are still on the tile before the entrance, but the entrance has the entry tile position, and that is the first destination we have to go to. For example, let's take our ball, put it here. Now we collide with the entrance, and then our ball is on that tile here, on that tile position, and the entrance has that position here. So the first thing we need to do is to go to that position. And after that, we have to look what the next tile is we have to move to. And here we only have the position of the tile, and again we need to convert it to the world space so we can move our player and use the transform position or the rigid body dot position. And we get that by asking the item map, give me the world position to the cell and the destination tile position. So that's that position here in world space. We are also adding here a tile anchor, and that is because I said every position, every world position of a tile is calculated in the lower left corner, and we want the middle of the tile so that the ball won't go here through the pipe but in the middle of the tube. And for every tile map you can set the anchor position of the tile, and that is 0.5, and that is exactly what we need to add to this lower left corner of the tile. We add 0.5 and end in the middle here. Then we initialize our waiting time object. So in each loop we're doing here, we're returning from the coroutine, and usually you would say yield return new wait for seconds, and by that in each loop we are creating new wait for seconds objects, and that is not necessary because the time does not change. So we are just creating one waiting time object here and using it here in our yield return. And once we know our first destination, we are doing the same here in a do while loop. So basically we are continuing the whole process while is tube at tile position, our current tile position. That means at the current tile position of our ball, as long as there are tube tiles, we continue with that loop. And once the player leaves the tile, then there will be a floor tile at the current tile position, and we can exit this loop and set the velocity in a way that the player will roll out a bit from the tube, and then we are enabling the player again and return from here. And in this loop here, what we do is while the distance to our destination position So while the destination to that position, that is where we want to go, while that is bigger than 0.16, you might wonder what value is that. That's also found by experimentation, and it's based upon how far we want to move the player in each iteration of this while loop here. And here we are moving it in the direction to the destination. So this means destination position subtracted transform position of our ball will give us a motion vector in the direction from the player to the destination. Normalized means it's normalized to a length of 1. And then we multiply that with 0.16, and then we are waiting for 0.02 seconds here with the yield return, and then again we are moving 0.16 units in the direction to the destination. So we're doing that increasingly until we reach our destination position. And as long as the distance to our destination is bigger than 0.16, we know we haven't reached our destination yet. We need to add another 0.16 units to that. And we might not end up perfectly on the destination position, but when we are close enough, we are leaving this moving while loop and set our tile positions accordingly. Our current tile position is set to the destination. Then a new destination position is calculated, and also the destination position in world space is again calculated by cell to world and adding the anchor point. So basically when we are reaching the first destination, the next destination is calculated, which is here, and then the next calculation is done and the destination is here, then here, then here, then here, and so on. And the next tube tile is calculated in that method, and that also needed a bit of experimentation, especially because we can rotate the tiles in the tile editor and place them. So we have some strange magic going on here by using get transform matrix and so on. And here are the various cases that have to be calculated, for example, when we're on a normal tube tile, that is this tile here, a straight tile, that can be rotated 90 degrees or it can be upwards. So that is taken into consideration by calculating the look direction. And when we're in the pipe, we are also having two possible tiles we can move to. For example, when we're down here, the next tile could be here or it could be here. So what we're doing is we check our current tile position and at the look direction. And if that is not the last tile position we were on, so that means we're not looking back in the last position where we're coming from. And if there is a tube tile position in the looking direction, then we return our current position, adding the look direction, and that will give us the next tile. But if the look direction turns out to be the direction where we came from, then we subtract the look direction and we'll check if that is the last tile position. And if it's not, if it's a new tile position we're looking at, then we're returning the current tile position minus the look direction. And here we have the various cases when we are on a tube right bottom tile or on the tube top right tile and so on. For example, let's take a look at the tube LT lower top. That means the tile has openings left and top. When we are on such a tile where we have left and top openings, then we first create a look direction to look above and check all this that we have done above for a normal tube tile. And if we're not successful by looking above, then maybe we came from above, so we have to look to the left and do the same. And in the end, we will just return the position of the next tube tile. And when no tube tile is found, then we just continue in the direction we came from. So that means when we're leaving the tube here, then there is no tube found in that direction, so we just continue in that direction. So we move just upwards. So that's quite a few cases we have to consider. So it may take a while for you to wrap your head around what's happening here. And that's not a bad thing. It took me quite a while to write this, so that's okay. Let's go back to where we came from. Here we get the next tube position and ride the tube until we arrive and find no further tube tile, and then we continue rolling out of the tube. So that is when we're colliding with a tube entry. The other case we can consider here is the check special tile object when we're colliding with anything. And here we will do a bit of optimization in another video. That's why we have this to-do comment here. But basically we're checking if we are hitting a damaging obstacle and then subtracting energy, and the damaging obstacle will give us how much damage per second we are taking here. And the velocity is also slowed down by dividing it by 1.25. And examples for the damaging obstacles are the normal explosions in the level. You can find those in level 2, and they are also game objects that replace tiles on the tile map. Here you have such an explosion that gets animated. And it also has an explosion script, and here we can tell the game, is that a passable object? Yes, it is. And how much damage per second does the player take? It's 10, so that gets subtracted every second when the player is colliding with that object. And in case you're wondering, we have an explosion script here, but here we're checking for eye damaging obstacle. That is because that is an interface that unites several objects that can apply damage to the player. We will take a closer look at that in another video. Let's go back. And lastly, check the check obstacle at position method. And here again, we check the position of the obstacle we have collided with in map space, in tile map space, by converting our position to the cell. Then we find out what that obstacle was by asking the obstacle map, give me the tile for that position. And usually anything on the obstacle tile map is not passable and just results in a bumping of that object. But we have two cases where we have to make an exception, and that is when we're hitting a cracked wall of type 01 or 02. Let's take a look at those in the tile palette. That are these two here. When you encounter such a wall and you have the extra of the armor ball equipped, so you get a metal plate around the ball, then you will be able to ram that wall and first transform it into that cracked wall, and when you hit it once more, then the wall will vanish at that position. And that is what we have here. When those cracked walls are the obstacles we have hit, we need a certain velocity, and also we have to activate an extra that can destroy walls. It doesn't have to be the metal ball. Right now it's the only extra that can do that, but we can add other extras that are capable of destroying walls. And then when we're hitting that wall, we decide what tile we want to set there. And when the obstacle was cracked wall 01, then we will replace that with cracked wall 02. Otherwise, we will set it to null, which means we will remove the wall completely. So that was quite a lot for the check for collisions method. Let's see what we have left here. In every frame, we want to check the floor, of course, where the player is. And here we have also several options. We have to check for cracks and for holes. We have to check the floor materials if we are on ice or normal floor. We have to check for the arrows, for hazards, for ramps, for extras, for price, and for exit. Let's go through each of them, check cracks and holes. Here we have simple checks if the current floor tile we are on is the cracked tile, that is the one only showing slight cracks. And when we have entered the tile freshly, we want to continue from the first crack to the first small hole tile. Or when we are staying on the tile for too long, here for 0.75 seconds, then also the transition to the next cracked tile is triggered. So that is why we are keeping track of the seconds on current tile in the calculate timers method. And so we're going from cracked tile 01 to 2 to 3, and lastly the tile is completely dissolved and the player can fall into the void. And that is checked here. If the current floor tile equals null, then the player falls into the void. Let's take a quick look here. The player gets disabled and the fall into void sequence is triggered. We took a look at that in the introduction, but basically what that does, it plays the falling sound, then it starts the coroutine for shrinking the ball. That just scales the ball down, so we have the illusion that the ball is falling down. It is getting smaller over time. Then we can have an extra selected. For example, there's a parachute that might help you and respawn you at the safe tile next to the hole. And if you don't have that activated, the lives will get decreased, you will be declared dead, and when you have lives left, you can choose if you want to respawn or want to restart the level, or else the game over panel is shown. One step up in the hierarchy. That was check cracks and holes. The next is check floor material, and here we have the differentiation between ice tiles and normal floor tiles, and crack tiles are the same in that regard, that we are changing the behavior on the tiles. We have seen earlier we have no velocity dampening, so we won't slow down on ice tiles. It is harder to control because our influence by adding force to the ball is halved. And also the rotation of the texture is a bit adjusted. So it seems that we are moving in place even when we're not moving. Let me show you that real quick. Here, that's the normal movement. And here on the ice tiles, you can see the ball is rotating in position. And that is achieved by adding this extra texture rotation. So you can add more floor tiles and add more effects to the velocity or the force scale. And where we're doing that is for the arrow tiles. These are also floor tiles. And what they do when we're encountering an arrow up tile, then our velocity gets a boost in the up direction. And that is by adding max force plus 0.02. So it's not possible, no matter how much force we apply using the mouse, it's not possible to traverse the arrows in the opposite direction. They will always have a stronger force to push us in the desired direction. Then we check for hazard tiles. Right now we have only water tiles or acid tiles. You can add other traps here. And the effect that has is right now, whenever we're on a water tile or acid tile, then the energy gets decreased over time. Similar for ramps. We check when we're entering a ramp, and a ramp are these here, for example. When we're rolling up here, then there will be a slight force that is pushing us down again, and the opposite on that direction. When we're rolling up here, then a force is applied in that direction. And that you can see here. When we're on the ramp left, then to the velocity the force is subtracted, and on the ramp right it is added. And also for the spawning tiles, upper left, upper right, lower left and lower right, that is the spawning position. There we can roll down from. You can see it here, these 4 tiles. They will always push us down. Extras and prices are also floor tiles. These are, for example, this hammer is an extra and this is a price, and these are extra tiles and these are the price tiles. You can combine them. You can, for example, in the tile palette, take the 900 price tile and put it here on the floor, and then the hammer will cost 900 coins. And that is checked in those 2 methods. Check price and check extras are very similar. So when we're on any of those price tiles, we will calculate the price for the tile, which basically means when we're on the price 100, then the price will be 100 and so on. And then when we can afford that, when our money is greater than the price, then we can buy an extra from that tile position. And since we have entered the price part of that label here, the 100 and not the hammer, we want to buy the extra from the tile position, that is the current position minus 1. So we have always here the tile with the extra and right of it the price. So the extra for that price is always 1 tile to the left. And similarly, when we are entering an extra tile like the parachute, bomb, spikes, armored ball or pickaxe extra, then we check for the price, but of course we're checking not at the current tile position because we have entered an extra tile and not the price tile. So we need to check one step to the right for the price, and then we can buy the extra from the current tile position we are on. And what that does is just subtracting the price from the money, play a sound, finding the right extra at that position, and calling buy on that. We will take a look at the whole extra system in the next video. But finally, when you're buying an extra, then the tile for that extra is replaced by a sold out left, and the tile with the price, which is one step to the right, is replaced by sold out right. So what basically happens is that the extra is replaced with that part and the price with that part. So in the end, you have a sold out here. And of course, when you're encountering the exit tile, then we will exit the level. And what that does is disabling the player is pausing the timer, because that is the time we have needed to complete the level, and then triggering the exit level sequence as coroutine, and that lets the player shrink. That simulates the falling down again, because that is a hole the player may fall into when they are exiting, and then they shrink, and the game manager is called with finished level, and the final time is displayed in the high score screen. And that is almost everything that is going on here in the player controller. It's really quite a lot, and it couldn't hurt to restructure it and divide it into smaller classes, but I hope you have got a nice overview. And there are a few things in here we haven't talked about, and they are related to the extra system we will take a look at in the next video. One more thing I want to point out as a workaround is when you're picking up coins. Coins are animated tiles, and these items here. Let's select the items layer. So you can see here the green outline, that is the collider of the animated tile. And it seems to be a bug that when we are collecting the tile and we're setting the tile to null, that the tile vanishes, that the collider won't get updated. And I assume it has to do with the fact that it's part of one big collider, the composite collider here. And as a workaround, because when we're collecting the coin, we want to pass it and not get bumped away by that collider. And as a workaround, what I did, I just took the item map composite collider, that is the composite collider on the item map, and called generate geometry. That will calculate the whole collider again. And it may be a bit costly, but it doesn't happen every frame, just when we're picking up a coin. So it is a workaround that's feasible, I think. So finally, that's it for that video. If you have any further questions, let me know in the comments, but I encourage you to study the code and to break it and to experiment with it and change values, and maybe start by adding 1,000 here instead of 100. And when you pick up a coin, you see that your money raises by 1,000 and not 100. And if that's too small, then maybe invent other items that you can pick up. Whatever you want. And if you don't know how to do it exactly, ask in the comments or come to the Discord and we can discuss any extensions or any questions you might have to that code in the player controller so far. I wish you great success with your endeavors in that code, and I hope to see you soon. Happy creating and take care.